In this video, we're going to look at comparing two graphs, and we're going to look at the graph of y equals x squared and y equals 3x squared. So first we want to plot both graphs. So we're just going to do like a t-chart here so we can get some x and y coordinates. So first let's just go through and do some kind of general x coordinates that we use a lot for parabolas. It's one of the easiest way to graph them if you just have a bunch of coordinates. So if we have 1 for x, if we square that, we just get 1. 2 gives us 4. Negative 2 gives us 4. Negative 1 gives us 1. 3 gives us 9. Negative 3 gives us 9. 4 gives us 16. And we'll just throw in a negative 4 so it can be even, and then we'll have another 16. So now let's do one last point with 0, and then we get 0. Let's go ahead and graph these points. So we have 1, 1, and we're going to make this scale by 2's on the y-axis and by 1's on the x-axis. So 1, 1 is going to be about here. We have 2, 4 here. We have 3, 9, about here, and then we have 4, 16, which is going to be up here. And now we're just going to fill in our negatives, which are essentially going to be the exact same, just on the negative side. And if we want to connect our points, we'll see that we get a rough shape of a parabola. May not be entirely perfect since I'm doing this by hand, but just a general shape here. Now let's do the same thing graphing the y equals 3x squared. We'll use our same points as before. So we have 0, 1, 2, 3, 4, and then negatives. And once again, we're going to have our scale go by 2's. So in the y direction. And we're going to go by 1's in the x direction. So when we have x of 0, we're going to get a y of 0. When x is equal to 1, we're going to get 3, because 1 squared is 1, times 3 is 3. When x is equal to 2, we're going to get a y of 12, because we know 2 squared is 4, times 3 gives us 12. 3 squared gives us 9, times 3 is 27. 4 squared is 16, times 3 gives us 48. And now we have our negatives, and we know those are the same as our positive numbers, so we'll have another 3, another 12, another 27, and 48, because those negatives will just cancel out whenever we do our squaring. So if we go ahead and plot this, we have another point at 0, 0. For 1 we have 3. For 2 we have 12. For 3, we had 27. So we said that was the 12 mark. So getting up to 27, we have, that's going to be all the way up here. We're going to have a 27 right here. So we're not actually even going to plot those 4's because those are just so high up that it's off our chart. So let's just go ahead and copy those points to the negative x side of our graph so we can get our full parabola shape. And then we can go ahead and draw in our line to connect these to make our parabola. as we can see on the previous graph, we were able to get all four, x equal 1, 2, 3, 4, all would fit on the same graph. But in our bottom one, our fourth point is going to be way off the charts. So by looking at the data, we see that the y equals 3x squared plot grows faster. And we know that's because of the coefficient. Because essentially, our y equals 3x squared graph is 3 times the y components of our y equals x squared graph. The y equals 3x squared is narrower, which is a sign of that fast growth. So when comparing different graphs, it's important to note, how increasing x-coordinates will affect the y-coordinates. So in this case, the y-coordinates got larger faster on the y equals 3x squared compared to the y equals x squared graph. Also, graphing them can be very helpful because, like we said, the narrowness of the y equals 3x squared graph helps to show us that it's growing faster.